Section 1.5, we're going to talk about the division of segments and angles. Some new vocabulary. So we have a point, a segment, a ray, or a line that divides a segment into two congruent segments is said to bisect the segment. The bisection point is called the midpoint. So that middle point is called the midpoint, and the segment is bisected. So if x, y, which is this one right here, so if that segment is what bisects AC at B, the question is, what conclusions can we draw? Well, based on the two new vocab words above, B would be considered to be the midpoint, and AB would be congruent to BC. Now, for example 2, it says if OK was congruent to KP, what conclusions can you draw? So, K is the midpoint of OP. JM, this segment right here, would then bisect OP. And then point K bisects OP. Many people look at that and they also think that JM would be bisected as well, but that is not the case. So don't make that conclusion based on that information. If they tell you which one is bisected, that is the one that is bisected. Don't draw any more conclusions based on other segments. So if we take the word bisect, extend it further. So now we have a segment that's divided into three congruent parts that's said to be trisected. The 2 points at which the segment is divided, those are called trisection points. So for bisect, we have a midpoint. For trisect, we have trisection points. All right, so again, only segments can have trisection points. You can't have them with rays or lines just because those extend infinitely in a particular direction. Example 3 says, if E and F are trisection points, so if E and F are trisection points, what conclusions can we draw? Well, if they're trisection points, that would have to be of DG. Then we know that DE is congruent to EF, which is congruent to FG. Those three would be congruent. And not only that, but the segment HE and the segment HF would be the trisectors. Those are the segments that are cutting that segment into three equal parts. We don't know anything about the angles. We can only say something in regards to the segments. So now a ray that divides an angle into two congruent angles bisects the angle. And the difference here is that dividing ray, it's called the bisector of the angle. So you are going to then reference that in a proof with the word angle bisector. So anytime an angle is being bisected, you're going to say definition angle bisector for that. Now, in this drawing, it says if angle ABD and angle DBC are congruent. So if this angle is congruent to this angle, then ray BD, not DB, it has to be BD starting at the vertex, is the bisector of angle ABC because it cuts it into two equal parts. And the same would go for a trisector. So if I drew, let's say, same angle we start with, ABC, but now I'm going to just add 2 rays in here. So one will have D on it, and one will have F on it. Okay, so if we know that this angle is congruent to this angle, which is congruent to this angle, then we would be able to say that BD and BF, both of those rays, are trisectors of angle ABC because it cuts it into 3 equal parts. All right, example number 4. Says, given that RS is congruent to ST, is S the midpoint of RT? Okay, just by looking at it, yes, we see that RS is congruent to ST, but in order for something to be a midpoint, they need to fall on the same line. In order for them to fall on the same line, S would have to be between them, and they do not. So the points are not collinear, therefore you cannot say that S is a midpoint. All right, it says if B and C trisect AD, so B and C, if they trisect AD, do rays EB and EC trisect angle AED. So if we know that B and C trisect, we know that AB is congruent to BC, which is congruent to CD. Okay, we know that EB and EC are trisectors of AD. So let me add that. So EB and EC are trisectors of AD. But again, similar to what I had mentioned in the previous example, you cannot make any conclusions based on the angles. Just because the segments are congruent does not necessarily mean that the sides, or not the sides, sorry, that the angles would be congruent. So again, if the sides are congruent based on the trisection, you cannot make any conclusions that the angles would also be congruent. All right, so let's try a proof here. So it says, given that DH is congruent to HF. So always important, label it on the picture. So it's a proof. So we know our first statement is going to be what the given says, and our first reason is going to be the word given. So we are trying to prove that H is the midpoint of DF. Well, if you look at the segment that we have right here, here's DF. And we just showed that we have two segments that are equal to each other. Well, if we have two segments that are equal to each other, that middle point has to act as a midpoint. So we go right to our proof statement. So this is just a two-liner. And the reason we're saying it, a lot of times in the statement, there's a hint at the vocabulary word. So it's talking about a midpoint. Therefore, the reason we are going to use for number 2 for the reason is definition of midpoint, which says that if you have a point in a segment that cuts something in half, then it is a midpoint. All right, ratio question for number 7. Says EH is divided by F and G in the ratio of 5 to 3 to 2 from left to right. If EH is equal to 30, find FG and name the midpoint itself. Okay, so what you could do is, again, anytime you're given a ratio question, you have to add a variable to it. So I'm going to add X, I'm going to add X, and I'm going to add X. So in the order, EF is 5X, 3X goes to FG, and then GH gets the 2X. And then the whole thing adds up to 30. So we have 5X plus 3X plus 2X equals 30, which means that's 10X equals 30, so X is 3. And then what you do is you're going to take that and sub that in